You know, deep in our own galaxy, something is blinking. It's this truly bizarre object, and it's sending out signals so strange they are literally challenging our fundamental understanding of the universe. Welcome to a real-life cosmic detective story. So that's the big question, right? What is this mysterious thing? Is it some kind of star we already know about that's just acting weird? Or could it be something entirely new? To figure that out, we have to follow the clues. All right, so our story kicks off with an object that has the catchy name ASKP J1832-0911. Now, it's about 15,000 light years from us, and yeah, that sounds super far, but in cosmic terms, that's practically in our galactic backyard. The very first hint that something strange was going on came from the incredible ASKAP radio telescope down in Australia. While it was scanning the skies, it picked up a radio signal that wasn't just some random burst. No, this thing was repeating, pulsing with a very specific and very, very strange rhythm. Okay, this is where our little detective story gets a massive break. You know, a lot of discoveries in astronomy come from years of careful planning, but sometimes you just get unbelievably lucky. And in this case, it was an absolutely massive stroke of cosmic luck. So to get why this was so unlikely, you have to picture the telescopes. The ASKAP telescope, the one that found the radio signal, it has this huge field of view. Think of it like a wide-angle security camera watching an entire parking lot. At the exact same time, NASA's Chandra X-ray Observatory, which has a tiny field of view, more like a microscope, just happened to be zoomed in on that exact same spot. What are the odds? And this quote from the lead author, Dr. Ziteng Wang, it just says it all. The object wasn't just sending out radio waves. It was also blasting out high-energy X-rays. And finding both signals at the same time from two different telescopes, well, that was the kind of once-in-a-career coincidence that can make an entire investigation. So, with these two huge clues in hand, the radio waves and the X-rays, astronomers could finally start building a profile of our culprit. And believe me, the more they looked, the weirder this thing got. The first truly bizarre fact is its timing. This object pulses on a 44-minute cycle. Now, to put that into perspective for you, the cosmic objects we normally think of as pulsing, things called pulsars, they can spin multiple times a second. 44 minutes is an absolute eternity in that world. So let's break that down. What does that 44-minute cycle actually look like? Well, for about 2 minutes, it's on, blasting out a bright flash of both radio waves and X-rays. Then, for the next 42 minutes, nothing. It goes completely quiet. On, then off. Kind of like a cosmic lighthouse with this really slow, really predictable rhythm. This strange behavior actually places our object into a recently discovered class of objects called long-period transients, or LPTs for short. And this is exactly what makes it such a landmark discovery. See, we've found a few LPTs before, but this is the very first one, the only one, ever seen to also be emitting X-rays. It's truly in a class of its own. And right when the astronomers thought they were maybe, just maybe, starting to get a handle on it, the object threw them a total curveball. They looked at it again 6 months later, and its signal had changed, dramatically. The radio pulses were now 1,000 times fainter. And the X-rays? Well, the X-rays were just gone. Poof. The mystery was getting deeper and deeper. Okay, so you've got this strange, changing evidence. It was time to line up the usual suspects. What kind of dead or dying star could possibly be behaving this way? The whole investigation started to focus on two main possibilities. Suspect number one is a magnetar. You can think of it as the superpowered, hyper-intense cousin of a neutron star. It's the incredibly dense, collapsed core of a massive star that went supernova, and it has a magnetic field that is almost unimaginably powerful. And then you've got suspect number two, a highly magnetized white dwarf. This is the kind of stellar remnant that gets left behind when a smaller star, a star like our own sun, runs out of fuel and dies. It's not as dense as a magnetar for sure, but some of these white dwarfs can also have incredibly strong magnetic fields. So, how do these two theories stack up? Well, the magnetar idea is pretty compelling. We know they have these extreme magnetic fields, and maybe an older, slower one could explain that 44-minute cycle. But then again, the white dwarf theory is also plausible, especially if it's got a companion star it's feeding off of. Both theories have their strengths, but as you're about to see, neither one is a slam-dunk case. And this is where our cosmic whodunit takes its most exciting turn. Just when you think you're closing in on an answer, The universe has a way of reminding us that it is always, always full of surprises. So, this is the million-dollar question, isn't it? After all of this, which one is it? Is it the magnetar, or is it the white dwarf? And the answer is, we don't know. Turns out, neither of the leading theories can fully explain everything the astronomers are seeing. The case is still wide open. And honestly, that's what makes this discovery so incredibly important for science.
So why don't these theories work? Well, for a magnetar, especially an old one, the radio signals are just way too bright and they change too much. And for the white dwarf theory to work, it would need a magnetic field stronger than any we have ever seen anywhere in our galaxy. Both explanations require us to basically stretch our current understanding of physics right to the breaking point.
So what this really means is that we are looking at some kind of cosmic object that just doesn't fit into our neat little categories. It's challenging the fundamental models we've built for how stars are born, how they live their lives, and how they eventually die. And that leaves us with this final, powerful thought. In science, when you find something that doesn't fit, that isn't a failure. That's an opportunity. This single, blinking object, 15,000 light-years away, might just be a clue, a signpost pointing us toward a new type of physics, or maybe a whole new understanding of the lives of stars. The mystery isn't solved. It's really just beginning.